Hello, fourth grade. You're still fourth graders in La Belle Aire, class of 2019 and 2020. And I am here today to talk about that and also get you started on the very end of Module 5, which is today's going to be lesson, I believe it's 35, lesson 36, and 37. And those lessons are all about that repeated addition of fractions as a multiplication problem of a whole number times a fraction. So if you haven't gotten this idea yet, Eureka is all about doing something in standard algorithm, but first showing you why it works and doing it step by step to help you remember how to do it. So in this case, we're going to be looking at multiplying a fraction times a whole number in different ways. And then we're going to do some larger multiplication problems with two mixed numbers, and we're going to use our good old distributive property, and we're going to get good at that. And we'll even look at a couple of word problems, and then later this week on Wednesday we are going to do some word problems for fractions. If you remember from your LEAP test, almost a third or maybe half the test was on fractions. A lot of your word problems will be something like you need 6 yards of, or you need six of something, and they're all worth 2/3 each, so you have to end up multiplying 6 times 2/3 to get your answer. I know a lot of you on that interim test didn't quite understand that, so here we are. We're going to explain it, we're going to practice it. Well, I hope we're going to practice it, because that's what I want to talk about next, because we're not getting we've gone down to almost zero participation. I know some new students popped up last week and said, oh, I want to do some work, but I don't know how much work you actually did. You might have looked at the video. I don't know if you went in your module book and you practiced it. I put out 2 time to climbs. I only got 2 people to play, and then on the second one no one has played it. So the participation levels have gone way down. I know you guys are staying up super late and playing around with the other things, and you're not actually doing your work if you have a computer. But here's what's coming. The district is asking schools to step up their outreach, and we're going to be calling you, we're going to be calling your parents, and we're going to be telling them, hey, school is still on. We're still doing school. Technically, we are going to be back on May 1st. I mean, as the order stands now. And some of you guys have not done any work. I know some of you have computers, but a lot of you aren't even trying. And we need to start setting up a system where you can show me that you know how to do the work. So we're going to be on a new platform soon. It's already set up. Fourth grade is there. I gave instructions on how to get on it. You go to Clever and log in and type in Microsoft Teams. You click on that app, and the team is there. You choose fourth grade. La Belle Aire Math is one of the classes. There, Miss Chris, Miss Van Buren, and Miss Moore will all have a class. And you log in, and we'll give out assignments there. And I'm still going to use Google Classroom to put assignments, but at the same time, I'm going to put out assignments on the Microsoft Teams platform that are going to be more like an assessment. Show me you know how to do the work. And I mean, even if you use a calculator at home, you still have to understand it, know how to do the steps, and give me an answer. You just don't know how to, if it's a high multiplication problem with 2 digits by 2 digits, you still need to be able to know how to do it and show it to me. Show me your work. And the other thing that Microsoft Teams platforms gives us the ability to is to actually video chat. So if you're having a problem with your work, the future might look like this, where you're doing online school, and if you need a conference, we can do a small group together and we can work together on video chat. And now my daughter is asking about watching TV. So she's done watching Bluey. Okay, so what we're going to do today is our multiplication of a whole number times fractions. See you on the whiteboard. here I am. Let's start on the whiteboard. And we are multiplying fractions and whole numbers. We're in Module 5, Lesson 35, Problem Sets, page 167. Remember what we're doing here now. I'm going to go over the problem sets for each module, and the Eureka videos are going over the homework problems. And I could simply tell you right now that the next three or four lessons are all about multiplying whole numbers times fractions. And all you have to do is multiply the top number, the numerator, times the whole number and put it back over the denominator. Denominator is not changing here. But what we want to do in Eureka is we take it step by step. We're teaching you what it means to do that. And normally we don't have a lot of time in class to do that, but since we're at home learning and we do have the time, we're going to do the module work, and I'm going to show you how to do the problem set so you're not clueless as when you look at this stuff. So if we look at this first problem, 1A on page 167, it says draw and label a tape diagram to show the following are true. So what's true here? Let's see. It says 8/5, and I put a little 1/5 up there to show that that is 1/5. Fifth means 1/5, and there's 8 of them. Okay, and then they're showing you that you could pull 8 apart into 4 times 2/5. And whenever we write the word fifth, we're actually writing this in unit form. This is considered unit form when you show the word for fifth. Okay? And then they say that 4 times 2/5 equals 4 times 2 by itself. That's the associative property times the fifth. Okay, there's two ways to do your tape diagram here. You could say this. You could say that you have 4 2/5. Okay? We could say that. So let's make 1, 2, 3. There's 4 in your tape diagram, and each one is worth 2/5. Okay? So what they're trying to do in Eureka is get you used to the idea that this top number is what's changing here, and that the bottom number is always staying the same. If I have 4 2/5, that also equals 2/5 plus 2/5 plus 2/5. There's your repeated addition. And if I add all these up, I get 8/5. Alright? Another way of doing this is you could have said 8/5. That would equal 1, 2, 3, 4, 5, 6, 7 lines gives you 8 spaces because it says 8/5, which is 1/5. The other way to write this would be 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5 is the same as 8 times 1/5, and that also gives you 8/5. Now, what does that equal as a mixed number? Well, let's find out what a whole number is. A whole number here would be in fifths. So 1, 2, 3, 4, 5 of these equals 1. And then you have 1, 2, 3/5 left over. So the mixed number is 1 3/5. Okay? That is only for number 1, and you want to do 1B by yourself. Let's look at number 2 next. Okay, now we're on number 2 on the same page, 167. And I picked C for our example here. And we're taking things a step further to show you what kind of problems we're talking about. Number 2 says write the expression in unit form to solve. So it's going to look a lot like number 1, except we're not going to make a tape diagram. But let's think about this. 16 times 3/8. We could say as a tape diagram that 16 times 3/8, that's not a mixed number. Remember, a mixed number would be a plus sign. This is actually saying 16 sets of 3/8, just like normal multiplication. If you look at it as a tape diagram, it'll be 3/8, 3/8, 3/8 added together 16 times. Or we can go ahead and solve like they want us to. So let's follow along. 16 times 3/8. What they want to do next here is say that this is actually 16 times 3 times 1/8. Okay? And then we would pull that out. We would take this number out of here. We would do the distributive property here a little bit. We can say 16 times 3/8. Okay, here's your unit form, 16 times 3/8. So that would also look like 16 times 3/8. Now the hardest part of this problem, of course, is to multiply 16 times 3. You need to practice your 2-digit times 1-digit multiplication. What are the steps? 1s times 1s. 3 times 6 is 18. Regroup the 1 in the tens place. Then we multiply 1s times 10s. 3 times 1 is 3, plus 1 is 4. I get 48/8. 48/8 is very simple. If we divide 8 into 48, if I want to make this a mixed number, 48 into 8. What is 48 divided by 8? Well, I know that 5 times 8 is 40, and 6 times 8 is 48, so that is equal to 6 whole numbers. So remember, on these particular problems, you just want to solve like this. Multiply this number times the top, back over 8, and change to a whole number if you can. Let's go to the next one. Okay, we're back and we're on page 168. And what we want to do now is, it just says solve for number 3. So what we want to do now is go directly to what we're talking about. When we're multiplying a whole number times a fraction, remember, we're talking about these top numbers. We're talking about 12/7/10. We can't do anything to this bottom number, the denominator. We're talking about how many parts of 10 do we have. And we have 12 times 7. So let's write it out one more time to look like this. 12 times 7/10. Okay? That can also be written as 12 times 7/10. Because this is actually 12 times 7 times 1/10, right? How many tenths do we actually have? Well, we have 12 times 7. So with these, all you've got to do is this hard math here. If you think it's hard, we have a whole number times 7. 7 times 2 is 14. Plus 1 over here. You have to add 1 to the 10th place after we multiply. 1 times 7 is 7. 7 plus 1 is 8. So that equals 84/10. I want y'all to get used to changing this back into a mixed number. How many tens, how many whole numbers do we have here? If we have 84 tenths, so division by 10 is easy, right? I know I at least have 8 tenths because 8 whole numbers. We have 8 times 1/10, right? 8 times 10 tenths gives us 80 tenths, and how many more do we need to go? We need 4 more. So let's rewrite that as 8 whole numbers. There's 8 tenths. That's 8 times 10 is 80, plus 4 tenths more. That's the remainder left over, 4 tenths. Okay, practice these. You have a few to do here, and we're going to look at a word problem real quick. Okay, we're back with this last problem in the problem set. It's number 4, and we're going to start looking at word problems now with fractions. This, of course, is going to be a problem that has a whole number times a fraction. We saw a lot of these on the LEAP test. It's very important to be able to solve this type of problem. It says Maria, and remember we're using our RDW technique, read, draw, write. And before we left, I was trying to show y'all in our IE groups that you want to start modeling this right away. So if it says Maria has 3.5 yards of fabric, 3/5 yard of fabric, not a whole yard yet, but 3/5 of a yard of fabric, for each costume. So let's imagine she's making Halloween costumes. This is how much yards of fabric she needs for each costume. And in this case, it's a fraction of a yard. Imagine this is a piece of her fabric, 3/5. Okay? And we want to go ahead and underline important facts and circle numbers. So 3/5 yard with the units, 3/5 yard of fabric. And I think for each costume is very important. And then it says, how many yards of fabric does she need for 6 costumes? And how many yards, of course, is the important question. How many yards of fabric? So if she needs 6 costumes, this is 1 costume, 2 costumes, 3 costumes, 4 costumes, 5 costumes, and here's the 6th costume right there. This would be the appropriate way to model it with a tape diagram. We could add all these up, or we can do our multiplication. 5, 6 costumes. Okay, let me get a different color to do the math. So this is part of our writing. We did the reading, we did the drawing, and now let's do the writing by making a math sentence. So we have 6 times 3/5 yards. Don't forget your units. Okay, so we're actually saying 6 times 3 over 5. 6 times 3 is 18, so that's 18/5. And if we added all these 3's up, we would get 18 too. And what is that as a mixed number? Well, let's think about how many sets of 5 are there in 18? How many 5/5 are in 18? Well, 5, the third multiple of 5 is 15. Let's see. Here's your first multiple, 3 times 1. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. That's still too low. And 3 times 5 is 15. So the 5th multiple is appropriate. That's 5. Okay, and how many left over? 15 minus 18 is 3/5 left over. So she needs 5 3/5 yards. Okay, it's that simple, guys. And I wanted to go ahead and do all the steps for you. And in the next couple of lessons, you'll be able to do more word problems like this. And I want you to answer them on your own. Let's move on to lesson 36. Okay, here we are. We're on the next lesson 36, page 371, and we're looking at number 1. Now, on number 1, what they're saying is draw a tape diagram to represent. So again, we're looking at this in another way with repeated addition, and we want to write a multiplication expression to equal that and solve, basically. So if we have these all lined up, your tape diagram is already made for you, right? All you have to do, when we get a different color, is take this addition sentence and make it a tape diagram, which is what I'm going to do. Okay, there's a tape diagram. Now make a multiplication sentence. This was just like you did before with multiplication and fractions. We're talking about 1, 2, 3, 4, 3/4, which is equal to 4 times 3/4. There's your multiplication sentence. And we can look at that as 4 times 3 on top over 4. That is equal to 12 over 4. And this should be very simple to find as a whole number or a mixed number. But I think it's going to be a whole number, right? How many sets of 4 are there in 12? There are 3 whole numbers there, 4/4. There are 3 sets of 4/4 there. That is your whole number. Do number 2 the same way. Let's go to the next one. Okay, let's move on to number 3B on the same page. And you can see that they're going to do exactly what we did on the first one, except they're not going to use a tick diagram. You've got, let me read the instructions. It says rewrite each repeated addition problem as a multiplication problem and solve. Express the result as a mixed number. Well, we did that on the first one, so it should be easy for you here. The first one has been started, so please do that one on your own, and I'm going to do B for you. So we have 3B, we have 3 9/10. So to represent that as a multiplication sentence, that is 3 times 9/10. We can look at that as 3 times 9 over 10. 3 times 9, that's the third multiple of 9. 9, 18. 9 plus 18 is 27. So 3 times 9 is 27 over 10. Now we go to a mixed number. How many sets of 10 are there in 27? Well, 27 divided by 10 gives you 2 to start off with. There's at least 2 groups of 10 over 10, and then there is 7 more left over, 7/10. 2 and 7/10. And if you've been practicing from the previous lessons and switching from an improper fraction to a mixed number, you should be good at this by now. 2 and 7/10 is your answer. Let's move on. Okay, now we're on page 172, and this is 4D. They want you to solve and turn back into a mixed number. And this is, again, a continuation of what we've been practicing, except now the numbers are getting a little bit bigger. So we have 26 times 7/8. By now you should realize that that is 26 times 7 over 8. What is the hard part here? The multiplication. Now if you plug this into a calculator and solve it, fine, but please know how to do this. 26 times 7. 7 times 6. The 6 multiple of 7 is 42. Am I right? 6 times, let's see, 7 times 5 is 35, and 7 plus 35 is 42. That's correct. All right, and I put a plus 4 here. 7 times 2 is 14. 14 plus 4 is 18. So look at that big number. So that equals 182. The denominator is not changing here. You have 182 eighths. And now we got to go back to a mixed number. How do we solve that? These numbers are bigger. Remember, this is a division problem. How many sets of 8 are there on 182? Well, you need to divide. Now, if you plug this into your calculator, you're going to be given a decimal as a remainder. Remember, we're talking about how many whole numbers do we have left over, and what is our remainder. On a calculator, it gives you decimal remainders. If we're doing it with a long division, we should get a fraction remainder. Let me show you. How many sets of 8 are there in 16? Well, we do our multiples on the side here. So that's the first multiple of 8 is 8. Second multiple of 8 is 16. 8 times 2 is 16. 8 times 3 is 24. That's too big. So we have to go with the second multiple. So we have, so far we have 16 whole numbers. So I write 16 here again, and I subtract, and I write 22. And now we're asking how many sets of 8 are in 22? Well, again, 24 is too big. 3 times 8 is 24. We got to stick with the 16 here. The 16th multiple. Oh, I did this wrong. This should be a 2. There's 2 times 8 is 16. And we need to use 2 times 8 again. 2 times 8 is 16. Get 16. I subtract. Now here's where that remainder comes in play as a fraction. 16 away from 22 is 8. Okay? 12 minus 6 is 6. 6 plus 16 equals 22. This becomes 1 minus 1 is 0. So 16 minus 22 is 6. So your fraction, this is the numerator. The 8 is still your denominator. Okay? So we're saying we have 22 whole numbers here, and the numerator 6, and 6 eighths left over. I hope that wasn't too confusing, but this is the steps you take to go back to a mixed number. If you do it on a calculator, you'd have to know that that decimal you're looking at is 6 eighths, and that's not easy to do. Okay? Let's look at the word problem here. Okay, now we're going to look at that word problem, number 5. And it says, remember we're doing RDW, it says, Morgan poured 9/10 liters of punch. Let me underline liters. She poured 9/10 liters of punch into each, that's important, of 6 bottles. So if I were to make a model, I would call this a bottle. I got 6 bottles. Here's my model. 1, 2, 3, 4, 5, 6. And she put 9/10 of punch in each one. And what is the question? The question is, how many liters of punch did she pour? And we're assuming that they mean all together, right? So all together, I could add up all of these up and then get a improper fraction that I have to turn back into a mixed number. But what we want to see here too is a multiplication. So here's the right part of RDW, the writing part. We have 6 times 9/10 liters, right? That is also going to look like 6 times 9 over 10. Okay? And we have to multiply 6 times 9. I know right off the bat that 6 times 9 is 54. So we have 54 tenths. Now this is an easy one to convert back to a mixed number to show us how many liters we have. If we have tenths here, that's so simple. I know that 5 times 10 is 50, so I have at least 5 whole numbers here. There are 5 sets of 10 in 54, and what is left over? Well, 50 minus 54 is 4. Back over the denominator, the remainder is 4/10, and it's in liters. Okay, I want you to look at each one of those word problems and try to solve and come up with a mixed number like this. Good luck. Now I'm going to move on to lesson 37, and that'll be it for this particular video. Okay, we're back on our last lesson for this particular video, and now we're going to get into something a little more advanced. We're going to use something called the distributive property, and if you remember what that means, distribute. Remember, I kept going over this. To distribute means to hand out the same thing to different people. So like if you're going to the store and they're handing out milk, they would distribute the milk. Or how about this, toilet paper? If we're going to give out 1 roll of toilet paper to each person because there's a limit on it, we would give out 1 roll of toilet paper, 1 roll of toilet paper, 1 roll of toilet paper. That's to distribute evenly. So in this case, in order to solve these larger problems where you're multiplying a whole number times a mixed number now, remember we were just doing a whole number times a fraction. Now we're doing a whole number times a mixed number. Here's what happens. You can take this 2 times 4 and 7/10 and turn it into this, because remember there's a plus sign here. That's 2 times, in parentheses, 4 plus 7/10. So what do I want to distribute? I want to distribute the 2 times. I want to distribute the 2 times 4, and I want to distribute that to the 7/10. So let's rewrite that as 2 times 4, okay? And I'll also want to distribute that to, okay, so what we're trying to say is 2 times 4 distributed to 2 times the 4 and the 2 times the 7/10. Remember, there's a plus sign in between it, plus 2 times 7/10. So now we have a normal multiplication problem with whole numbers, and then we have the simpler multiplication times a fraction problem that we've been practicing. So let's rewrite that. So let's solve this and then solve this and add them together. So 2 times 4 is 8 plus 2 times 7/10. Let's solve that one. Okay, so again we have 8 plus 2 times 7/10. Remember, just go straight across and multiply that 2 times 7. That's 14 over 10. I can rewrite that as a mixed number that is 8 and 14/10. But now I need to turn this into a mixed number where the 14/10 is not an improper fraction but a normal fraction. So we have 8 plus 14/10. This is what we call simplifying, guys. You can't do this on a calculator. Okay, 14/10. How many sets of 10 are there in 14? Well, there is 1 set of 10 in 14 with 4/10 left over. 10 times 1 is 10. 10 plus 4 is 14 over 10. So now all we have to do, remember this is all addition. 8 plus 1 is 9 and 4/10 left over. Okay? I want y'all to look at these steps, pause it if you need to, make sure you understand it, and then do some more practice in this lesson. Okay, I'm going to do one more problem from this lesson for you, and I want you to do the word problem on page 176 on your own. Right? Yeah. Do that one on your own, but I'm going to practice one more of these for you. You should be able to read the word problem now and understand what you're multiplying to get your answer. The tricky part is, of course, the distributive property and turning back into a mixed number. So let's practice one more time. I'm looking at 2h now. 2h on page 176. It says 5 and 6/8 times 4. Now the numbers are reversed here, but it's still the same thing. I want to distribute the 4 times the 5 and times the 6/8, because remember, there is a plus sign right here in this mixed number. Okay? So we want to distribute the 4 times the 6/8 and the 4 times the 5. So let's rewrite that as 4 times 5 plus 4 times 6/8. Let me keep simplifying to get my answer. To simplify means to solve in the parentheses first, then add, then convert to a mixed number that makes sense without improper fractions. So 4 times 5 is 20. So this part is solved, plus 4 times 6/8. Well, 4 times 6 is 24 over 8. Okay? This could be represented as a mixed number, but we want to convert this 24/8 first. How many sets of 8 are there in 24? How many sets of 8 are there in 24? Or what is 24 divided by 8? Well, 8 times 3 is 24, and I don't think there's any remainders here. There's no mixed number. So 24/8 equals 3. And 20 plus 3 equals 23. So sometimes your answer is already converted for you. I want you to keep practicing this. Keep practicing converting improper fractions to whole numbers. Practice, 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 practice to get good at this. And like I said, I want to make some way on Microsoft Teams that you can do an assessment and show me you know how to do this. I'm still working the kinks out on that, but that's coming soon. And of course, guys, you need to stay productive. It's very important that you stay productive. We're still in our school year, and we're in a whole new world now where it's going to be on you, just kind of like college students. It's on you to do the practice and get better. We help with the videos, and we'll help in the future with small groups and video conferencing, but It's up to you guys to practice. And that's really hard to do, to motivate yourself to do those things. I'm doing some other things too to fill in the time. I'm going to continue doing my Spanish lessons. Hopefully, by the end of the summer, I should be a lot better at my Spanish. But I'm also trying to pick up how to do the Japanese alphabet and start reading Japanese and start speaking more Japanese. So that's one of my goals. You guys need to have some practical goals like that. Learn something new. Learn how to play the guitar. Learn how to play the piano. Learn how to do some coding. Do something that's productive that will help you later in life. And we're going to come back together. We're going to do 2 more lessons in this module, and whew, that module book is done. And I'm going to start giving you work from module 6. You're going to have to copy down the problems. I'm going to put the pages out for you. You have to rewrite them. I'm going to show you how to solve them. We're going to learn how to do decimals next. So, have a good time. Don't stay up too late. Wash your hands, and we'll see you soon. Bye-bye.